So today's session is specifically on visualizations. So many of the cases, what we need is like, though we have the data set, we cannot go line by line or record by record to understand how the data looks like. So if you can show those numbers or those text in form of figure, then it will be very easy for us to make some judgments on the data set. Uh, Usually, when we start off with visualizations, we generally use this matplotlib or seaborn, but I would be emphasizing more on Plotly Express because this is one of the library which is too good in showing the visualizations. Matplotlib and PyPlot, if you understand the context of how to which graph to use on which kind of column, then you can usually look for that code in Google and try out that one. Okay, but given a couple of cases, I will also use this Matplotlib and Seaborn and try to show you. So let us spin up the instance and import necessary libraries. Because we are talking about a structured data, we'll be requiring pandas and numpy, and also we'll be requiring something like plotly express. Okay, so once we import that, uh, we have one more function just to convert all the columns to uppercase. So what I'm doing is I'm just taking an input data frame and I'm just rewriting the column names as call.upper so that all the column names are shown as upper columns. So 1 minute. So once you load the data, this is how the data looks like. This is how the data looks like. So you have average monthly hours, we have department ID, filed complaint, last violation, and so on. Okay. Maybe this data set is to figure out which person is going to remain in the company or which person is about to leave the company. So looking at the data who has already left the company, we have to figure out if a given person is going to continue with the company or going to leave the company. So in other words, it is called as an attrition rate. We have to figure out the attrition rate and help the HR team understand if a person is going to stay or if the person is not going to stay. So if they identify if that person is going to go out from the company, maybe they can look into it and make the person comfortable in times of monetary gains or in times of uh, based on if the person is having any problems in the company, like he has filed a complaint or not. Based on many such attributes, they have to figure out if a person is going to remain or not remain in the company. Okay. We are not applying any machine learning task here. We are just trying to visualize the data and see what the data says. Uh, First, we'll go and look at how many number of null values we have. As of now, we do not have any null values. We don't have to worry about the null values. But what we are trying to figure out is we want to look at the data and visualize the data, how the data looks like. Okay. First, we'll go with a univariate categorical analysis. So when I say univariate, it means that it is only looking at one column. Okay, whenever I say univariate, it is going to look at one column. And when I say univariate categorical data, that column is a categorical column. And if I say univariate continuous data, it is a continuous column. Okay, based on that. So first we'll look at the univariate analysis of a categorical column. For example, I have taken department name here. If you want to go out and try with some other categorical feature, you can simply rename, you can simply change the column name and execute this code. So when I look at department name, I have these many departments in that company. So we have product, sales, support, some engineering, procurement, and temporary guys or finance, and many other. Looking at this particular column, the obvious choice that you can do is count. So how many people are there in product? How many people are there in sales? How many people are there in support and so on? So to get counts, what you'll do, we'll use value underscore counts. So when you use employee data followed by the column name dot value counts, you get how many records are there for sales, how many records are there for engineering, how many records are there for support, and so on. Okay, this is how you get the value counts, and you can also get the unique counts by using n unique. So when you do n unique, you get the number of unique values that are present in that particular column. So I have only 11 columns. Okay. So the first thing what we can do is plot this count. So on the x-axis, we would have the columns, and on the y-axis you have the count. For each column, what is the count? Say, for example, this is your support, this is your IT, this is your HR, and so on. So this is how you can go and plot the column. So in order to plot a column, you need to define. Here I will be using matplotlib. And matplotlib, we have to first define how much canvas that you want. So if you want to define the canvas, we will use plt.figure and the size of the figure. So this is my width and this is my height. So you can see the width is pretty long and the height is less. So the first value will be your width, second column will be your height. And when I can use seaborn, in seaborn you have something called as count plot. I'm going to say that uh, my x-axis will be column name called department, and my data is nothing but my employee data. When I go and execute this, it will show me the count for uh, each value. Say, for example, product we have like close to 1500, and sales we have close to 3800 or something, and so on. This is how the distribution looks like. Okay. One more thing which you can do on categorical data is a pie chart. So pie chart is something like, it looks like a pizza. 1 minute. So the second choice is pie chart. In pie chart, you can have divisions. So this part belongs to sales, and this part belongs to product, this part belongs to admin, and so on. So what you're trying to do is you're trying to divide one circle into, based on the number of counts, you're trying to divide it into respective regions for each of the category. And then how we do that is like we can get a count. So for getting the count, you can also do a group by, and you count the department IDs. So when you do that, you get some records like this. So you have a department name, a department ID. It is same like what you did earlier. In value counts, it is directly giving, for sales, it is how much count. Similar to value counts, we can also do a group by and pick any random column for uh, for getting the counts. So what I did a group by on department name. That is how it sees department name as an index. So this is an index, admin is an index, engineering is an index. For each index, it goes and counts how many times it has repeated. For admin, it has repeated 175 times. So if we go up and see admin, it is 175. It's the same thing. Okay. And now what we're going to do is we will go and rename it as count. And then I'll go and plot it. So uh, uh, whatever code I have written so far, I did it in single go. So for first one, what I did a group by, then I did a reset index. After reset index, I went and renamed it. Okay. So you can do all these three steps in single go. That is how you can reduce the code footprints. So what I did, I just did a group by first, aggregated on department ID. After that, I did a reset index. After that, I went and did rename. So these are three steps written in one single line. So when you are getting comfortable to it, you can do this in, like, you can club multiple lines to a single line and assign it back to some new variable so that you can pick from here. Now, this department count is nothing but it is looking like this. You have a department name and you have a count. Okay. And again, I'm going to use matplotlib. In matplotlib, you have dot bar, which is going to show the count plot, and then it is going to plot and show you how the plot looks like. So for each variable, you'll have the plot. So it is nothing but on the y-axis you have the count, and on the x-axis you have the respective variable falling under the same column name. Again, you can also use the same dataset for showing the seaborn plot. Seaborn can show it in a more colorful way as compared to matplotlib, but it is the same axis. Only thing that is that the values are little jumbled. Okay. The second part, as I told, is a pie chart. Now, in pie chart, there are a couple of things that we need to do. First, we need to find out, again, we need to find out what is a count. So I have count as one of the axis, and I have labels. So for each count, I need to go and show what are the labels. And then if you want to go and take one part out of it, say for example, let me comment this code. I'll explain you. Give me a minute. Let us say when you go and plot a pie diagram, it looks like this. Okay, and I want to make it a little more beautiful by taking. You can imagine that you remove a part of pizza out, right? So you can do that by taking one piece out and show it. So in order to do that, we can use this explode. So by default, it is like all zeros. So what I'll do is I'll randomly pick one index out of that explode, and I'll mark that index as 0.2. So you already know how to use random. I'll say random.randint. What is my start number? What is my end number? In this case, my end number is the length of explode. To that random index, I'm going to say that the value is not 0, it is 0.2. When I go and execute this one more time, see it has chosen this 0.2, and whichever is this index, that index is falling out of the pie chart. That is how this looks beautiful. And then so far so good. So we have count plot and we have pie chart for categorical univariate analysis. These are the two things which obviously comes to our mind. One is a count and one is a pie diagram. For continuous data, I hope you already know what is a continuous data. What we'll be looking at is distribution. So in this continuous data, we have something called as KD plots, which looks like this, which will show you a bell curve, or you can have the histogram plots, which will look like this. Or this third choice is a box plot. I'll show you about box plot also. The box plot looks like this. The data frame looks like, I mean, the when you plot it, it looks like this. You have a upper whisker, lower whisker, and some distribution along with some mean. Okay, this is how the box plot looks. So we have KDE plot, we have histogram, and then we have box plot, and we also have one more plot which is like density plot. I'll show you. So like four different plots you can try out and show how the data set looks like. So the first one is histogram plot. How you can show a histogram is by using plt.hist followed by what is your x-axis and what is your data set. So when I do that, it shows the data. On the x-axis, it shows the bins, like it is ranging from 50 to like say 320, and wherever the density is high, there you'll have high peaks. Okay, this is a histogram plot. KD plot looks like this. KD plot, it shows the distribution. Wherever the distribution is pretty high, you'll find a peak. In this case, the distribution is pretty high around 150 and also around 250. So at 150 and 250, you have a lot of uh, occurrences. That is why you have a sharp peak in these two areas. Okay, you can also use ruck plots. Ruck plot is pretty similar to showing the density. Wherever you have dense, you will find big numbers like this. I mean, you can imagine, you can see, right? 1 minute, let me annotate it. So when you look at KD plot, these plots, there is pretty dense, and if you notice here, the density is very less. So wherever there is a dense, you'll see very thick lines, and wherever the dense is very less, density is less, you'll see very flat lines. This is one more option for using showing the density of a continuous column is ruck plots. You can mix two columns. Say for example, if I want to mix the KD plot and ruck plot, I can do that in the same figure. So I've taken one figure from canvas from matplotlib. I have said like it should be 10 by 7. 10 is my width, 7 is my height. And then I'm using seaborn for plotting my KD plot and average monthly hours, and ruck plot for average monthly hours. It's the same thing. Like you have to specify what is the x-axis. So in this case, my x-axis average monthly hours, and then if you want to fill it or if you want to just plot it by the line, you can do that also. And when I run this, it will combine two plots and show as one. Okay. We can similarly also do that for multiple columns. Say, for example, if I want to use on satisfaction, I'll just rename my column as satisfaction, and I can do that. You can see that KD plot and rug plot are coming. We can also look at box plot, which I just told you. So box plot is something to show if there are any outlets. This is obvious thing. So other than box plot, we also have Voilin charts. We can also use Voilin charts to show if there are any outlets, but box plot is more easy to interpret. So this looks like a uniform distribution because you do not have any outlets. So if you have any outlets, you will find out some dots here or on the lower end. Because we do not have any outlets, we do not see these things. Okay, and then you have the mean. What is the first quantile? What is the second quantile? And your upper whisker and lower whisker. Okay, we will use this again when we are talking about machine learning. At the time of machine learning, when we have to deal with replacing the null values, again we'll be looking at this box plot, and based on the box plot, we'll be treating those noise. Okay, but for now, we can imagine when there is a continuous column and single feature, you can use box plot to see if there is any outliers in the data or not. Similarly, for satisfaction, satisfaction is also a continuous column, and then you see a box plot, it looks similar to it, right? Okay, we can mix two different KDE plots. I mean, you can merge two continuous columns. Say, for example, I have a last evaluation and satisfaction. I can combine them in a single plot and see how it looks like. So you have a blue color one that comes for last evaluation and the red color one coming from satisfaction. You can combine two plots and see how the distribution looks like. Okay. So far so good, right? We have discussed about univariate analysis. In univariate, we have taken first one as a categorical column. In categorical data, we have seen how a count plot looks like and how a pie chart looks like. And then we came to univariate continuous column. We saw four different plots. One is your histogram, second is your KDE, third is your rug plot, and fourth is your box plot. You can also use violin plots. I'll show you later on, but if you want to choose violin plots, you can also see that. Okay, and then we will go to bivariate analysis. Say, for example, you want to understand what is the effect of one variable on another variable. Say in this case, my target column is attrition. I want to understand what happens to attrition based on my number of working hours, or what happens to my satisfaction based on my number of working hours. So whenever there are two columns and you want to see how they form, how they look like when I plot it, we can use bivariate analysis. In bivariate analysis, let us say that we are talking about two continuous columns. The obvious choice for you to show two continuous column is by using a scatter plot. So when I do a scatter plot in seaborn, you have something called as SNS dot scatter plot. You have to say what is your x-axis and what is your y-axis, and then it tries to plot both the things on a scatter plot and show how the density looks like. So looking at this, you should be able to interpret when you plot a data. Say, for example, if you do not know what the graph is trying to show, if you are unable to explain it, there is no point in showing that to the user. But if you look at this particular plot, there are a couple of regions where the density is pretty huge. So this is one region. This is another region. And there are a couple of regions where the scatter is very pretty less. Okay. So three regions are there. Region number 1, region number 2, and region number 3. So this is like average monthly hours. So what happens is like we are trying to plot average monthly hours against satisfaction. Now, satisfaction is 1 is very high satisfied, 0 is not at all satisfied. Okay. Average monthly hours is in a month, how much hours an employee is working. Say we are having a range from 50 to 300. So as the average number of monthly hours are increasing, there are a couple of employees who are not satisfied, and there are also a couple of employees who are pretty much satisfied. So this is where the data says that more number of working hours, but the employee satisfaction is also huge. Okay, but there are a couple of data where your working hours are pretty high, but your satisfaction is not good. Your satisfaction is pretty low. Okay, so when you plot the data, you should be able to draw some conclusions looking at the data. If you are unable to draw any conclusions looking at the data, it is better that you don't show the graph. I mean, you can show any number of any graphs that you want, but if you are unable to make any interpretation, then it is good that it is you should not show it. Okay, so for now, if you want to plot two continuous columns, scatter plot becomes an obvious choice to show the density, and this is how it looks like. And as I said, like if you do not know how the plot looks like, if you are unable to make any interpretation, it is not good to show. So one such example is this. On the x-axis, I have the categorical feature, which is nothing but my department name. And on the y-axis, I have the satisfaction. So it says that for each department, you have all such employees who are very poorly satisfied, we are very highly satisfied, and so on. Okay, but you cannot make an interpretation here because it shows that you have a scatter. Like let's say if for example in sales you saw like about 1500 employees are there, and they are fairly divided. Some people are very highly satisfied, some people are not pretty satisfied, some people are averagely satisfied, and so on. That is why the charts look like this. Okay, this is one such plot. Again, this is a bivariate for one categorical feature and one continuous feature. Similarly, you can have a scatter plot with rug plot with last evaluation and satisfaction. You can see when I go and scatter it. Again, you can draw some conclusions. There are a couple of areas where people, the last evaluation is pretty high, but the satisfaction is pretty low. Okay, these are highly evaluated people. It means that their rating were very high, but they are not satisfied. What happens when a person is performing well but he is not satisfied? It is high likely that the person can leave. Okay, but I did not have a third feature here. What is my third feature? If the person left or still continuing with my company. So if I have to use a third column here, I can do it. How can I do it? So in this case, I'm going to do a scatter plot, right? You have x-axis, you have y-axis. I'm going to scatter it somewhere. So if I want to use a third feature, I can change the color and do it. So my third feature can be this one, a different color. So if I want to use a different color, I can do that. Here I did not use color. So if I go and use color, I'll use a third feature here. That I'll tell at a later point. But for now, you can see that if you want to use two continuous columns, you can use a scatter plot and show it. We can also have something called a strip plot to show what the one categorical column and one continuous column, how they differ. So you can notice that the temporary department is standing out from the other departments. Not only the temporary department, even the admin department is standing out. And engineering is pretty huge, where they have too much of variance in the monthly working hours, average monthly working hours. So this is one strip plot which you can use, and you can also go with histogram that we already saw. Histogram we don't have to say. Okay, histogram. You saw that we have used histogram to show the counts. Like you have, say for example, you have a department called product. In product, you know what is the count. But what if I want to use another feature in this and show it differently? In this case, I want to see the status if the person left the company or still continuing with the company. So if I want to use third column as my color feature, then I can go and use color. So when I go and use color, it's the same histogram. So here also we have histogram. I have in color, I have department name, right? In this case, I'm going to use color as my status. So whoever has left the company, it is in blue color, and whoever is employed, it is in red color. You can notice the uh, legend here on the right side. So in order to show it, I mean, this is coming from plotly px. I'm here also like px histogram, but in this case I'm saying that my color should be third variable, which is nothing but status. So in product we have these many employees who have employed and these many people who have left the company. So for each department you see two colors: how many people have left and how many people have are still continuing with the company. And if you notice, the sales and engineering, these two departments are pretty huge, where the people are leaving the company. Okay, you can also use histogram with some different column. Say for example, instead of color as status, I'll be using recently promoted. So when I look at recently promoted, you can see that in all the departments there are fairly a number of people who are recently promoted. I mean, pretty less number of people who are getting promoted. And in temporary department, you don't have any promotions. It is obvious, right? You don't give promotions to contract roles. Similarly, for pie chart also, you can use a different color. Say for example, I have values as count. You can say title as department. You can show this is how the pie chart looks like in plotly. Okay, I think we have discussed all this. I don't want to go in detail. One thing which I want to show you before ending this session is trying to show more number of features. Say for example, so far we discussed about bivariate analysis, right? On x-axis you're taking a feature, y-axis you're taking a feature. What happens if you want to include more number of features? So in third axis, I can use color, or I can use shape, or I can use size. Okay, this is how you can club more and more number of features to it when you're plotting the diagram. So how to do that is by simply specifying what should be the shape or what should be the size. So for example, we have one such column. You can go through all this. I think it is not much important, but uh, one area which I want to show you before closing the session is, yeah, yeah, this one. Okay, let us say you have a scatter plot, and in scatter plot we take x-axis as satisfaction and y-axis as evaluation, but I want to color based on status. Now, as I said, status, the blue color is left and the red color is employed. When I go and run it, you can see couple of clusters. Okay, this is cluster 1, this is cluster 2, and this is cluster 3. You see the blue dots hidden behind the red one, right? So these are the three clusters which are fairly visible to us. So we are trying to plot the satisfaction, you're trying to plot the last evaluation, and then you're also using a third category, which is nothing but the status. Okay, by looking at this, there are a couple of employees who are performing very well. Okay, they are highly performed, they are performing very well, but their satisfaction is very poor. Eventually what has happened, they have left the company. Okay, these people, this is very problematic for the company. Like, these are leaving the company despite their very high performance. Why? Because they are leaving because they are not satisfied. So you're using a plot to show this intuition to the end user. Maybe you can show this to the HR department and say that you have good number of people who are performing very high, but their satisfaction is very low. Why they're not satisfied is secondary. But you can show this to the HR department and say, boss, they are not satisfied, and that is why they are leaving it. And you can also see they are pretty satisfied, they are performing very well, but still they are leaving the company. So this could be one more reason. And there are a couple of other people who are not satisfied and not performing, and they're also leaving. This is a very less impact impacting area, but these two are very highly impacted. This area and this area. So this is one way of using plots to show what you're trying to show to the end user. Okay, because by looking at the data, it is very difficult for you to analyze. But the same way, you can plot it and show the end user which feature is creating how much of impact. Okay, this is one way of showing it. Meeting is going to end. One more way is to other way is like I have used file complete. The graph is not visible on screen, but you can notice the yellow color lines for file complete and blue color dots for not file complete. Okay, I think it will look better on your screen. Through screen share, it is not that impactful. Okay, I can also use shape. Say for example, we have seen 3 features, right? Instead of 3 features, I can also use 4 features. So I have satisfaction, I have last evaluation. I want to see which person has left the company or not left the company. At the same time, I want to understand how much is the average monthly working hours. So bigger is the shape, bigger is the uh, working hours. Different color means if the person has left the company or if the person has not left the company. And again, on the x-axis is satisfaction, on the y-axis last evaluation. So I've used 4 features here to show, but it doesn't look so meaningful because it has covered the orange color data is completely covered it. But you can notice the different size, right? One you have square, one you have circles. So you can plot 4 features to it and show how the data looks like. And okay, in this case, I have used 5. The circle represent filed complaint. So if the circle, it means that filed complaint is 0. If it is square, it has filed complaint. So 5 features I have shown in one single graph. Maybe what you can do is instead of taking the whole data, you can try out taking only one department and see what the department says. Say, for example, I'm taking the whole company. Don't take the whole company. You can go and subset this particular company for sales alone. How to subset again? You can, right? You can just use employee data and say my department name is sales. Maybe like this. I'm not going to do that because you can try it out. After subsetting, you can just try out this one particular feature and see by using 5 different columns how to plot it. Okay. Similarly, you can also do for again we have a scatter plot for status and satisfaction and average monthly hours. You can notice that the satisfaction is pretty poor when the average monthly working hours is pretty high. Okay, this is one cluster. This is one more cluster. And at last, you can have a scatter matrix. When you have scatter matrix, what it will do, it will try to plot all the features with all other features. Say, for example, I have average monthly hours. Here also you have average monthly hours. And the red color shows it has left and the blue color shows they are still with the company. Notice how the graph is trying to tell a peak. Everywhere your average monthly working hours is high, it is standing out like these people are leaving the company. So simply by plotting, you're able to make some conclusions. In other words, you're drawing out patterns from the plots. Okay, so you can run this file. I'll just upload it in Git. You can just download this and try to go finer details. Maybe you can take, instead of looking at the whole company, you can specify and try out with one particular department and see if what the department is trying to say. Okay, so I have written down the key observations from the plots for your reference. So you can just see if this observations make meaningful or not. Sorry, I'm out of charge. Okay, any doubts so far? I think we should be good for today's session. This is all about visualizations that we can do in Python.
Huge.
Okay.
Just we can create only graphs with this one, right? We cannot create tables.
No, I think this is specifically for visualizing the data. So if you want to put it as tables, then we can store it as a data frame, and you can put it to a CSV file and all.
Okay.
Okay, but I think I would highly recommend you to take this notebook and execute line by line. Try out with different features, like try out different columns and see what is the output looks like, and how to draw conclusions from that particular feature or plot.
Okay.
Okay,
Cool.
thank you for today. Then we'll catch up in the next week again.
Sure. Thanks.
Thank you. Happy
Thanks,
weekend.
Joe.
Happy weekend.
Thank you. Bye.
Bye bye.